All right, so this is the Polynomials performance task. So we're going to read it first together, and then we're going to annotate. You don't read and annotate at the same time. I'd like you to read first, then go back and see if we can comprehend, okay? Kate is making an open wooden toy box to hold the building blocks at her daycare center. She has a square panel of cedar with side lengths of 24 inches. The first step is to cut out congruent squares from each corner. She needs to know what the side length of the cutout square should be in order for the finished box to have the greatest volume possible. We just read it, right? Did we comprehend some of it? All of it? We'll see. So the first thing I want to do is, what's the question? And it may not have a question mark. It might be, what's the task? Like, ultimately, what is the goal of what we're trying to find? So if I ask you to underline what the goal is, or underline the question, what's your ultimate task here of what we're trying to find? Could you underline it? So what is a good word? Why is what a good word? Because it indicates a question, doesn't it? So what the side length of the cutout squares should be in order for the finished box to have the greatest volume possible. So our big goal is to be able to know how to make this box so it has the biggest volume possible. Now, volume is a big math word, right? So now we're going to go back and start boxing out some key words. So when you think there's a key math word that matters, some words don't matter, right? They're fluff. But some words matter to solve it. So when you think there's an important word, let me know. Kate is making an open wooden toy box to hold the building blocks at her daycare center. Do you see any math words that would be important to us for our problem? Does it matter her name is Kate? Does it matter it's made out of wood? Does it matter she works at a daycare center? These are all fluff words, right? But there is one word that does matter that's going to help us. That is the word open and the word box. Does it matter what the shape is? It's a box. What does it mean that it's an open box? It means there's no top, no lid on the top. Is that, math-wise, will that matter when I design this box? Okay, read the next sentence and see if you can box out the important words, not the fluff words. Go for it. You read it. Can you box it out, something that's important? We're trying to build our comprehension skills, right? Our confidence. So you're reading the next sentence and putting a box around key words. Can you do that for me, please, before I do? All right, let me read the next one. She has a square panel of cedar with side length of 24 inches. So, does it matter that it's made out of cedar? Do you even know what cedar is? It's a type of wood. Good. Does it matter that it's a square? Good, thank you. Does it matter in terms of the side length? And we're going to not put a box around, but we're going to circle the number 24. And it could well matter the unit of measurement, right? In this case, the unit of measurement is in inches. All right, read the next sentence. We're going to do the same thing. You read it. You put a box around. It's work to comprehend. It's not as much work to just read. When you read the next sentence, what is a word do you put a box around? Congruent. Do you know what that word means? If someone says, what does the word congruent mean in your own words? April, you need to come up here and grab what we're doing, okay? Any idea? I know it's a geometry word. I bet you heard it last year, or maybe in Math 1, whatever. It's a math word you heard of. Now tell me, if I'm a 5-year-old, what does the word congruent mean? Same size, doesn't it? Can you say that? Like, if they're congruent squares, what does that mean? All squares are the same size, right? Do you understand that word if I say same size? So they put a fancy word in there. Congruent. Now, the next ones we underlined, right? in terms of what's happening. So let's read number 1 and see if we can go back to the actual prompt to help us have a strategy to know how we're going to answer it. So first it says, draw a sketch to help solve the problem. So even in math, especially in math, it's like reading. Is it better to read a book with pictures that give you clues to the comprehension, or do you rather not have pictures? Pictures always help, right? Always. Draw a sketch to help solve the problem. It says, hint, draw a sketch of the wood before the cuts and after the cuts. So let's go back and think, what material, what do we know about it? So we know it's wood, but more importantly, what shape is the material? So do you know what I'm going to draw? A square. So I need you to picture that square is made out of cedar. Is there any information I know about that square that I could detail on that picture? The side length. I like that, Larissa. What do we know about the side length? Do you know a quick symbol for inches? It is IN. Do you know another one? That if you have 2 tick marks by a number, it means inches. If I had 1 tick mark by the number, it would mean feet. Like if I said, how tall are you? And you say that you are 5 feet 10, you could quickly write down 5 feet 10 inches, right? And you can do it with tick marks. Have you ever seen tick marks like that with feet and inches? Who says, right, that you can't always learn something, right, when you do that? One day you might be that person that goes to Home Depot, right, on Saturday morning to try to fix something in your house. Do you know that? It might be you, that you might have to figure some of the stuff out. All right, what's the top side length? What's the side? What's all the side lengths? So they're all 24. And in geometry, have you ever seen that you can put a tick mark on the sides? And what it does is it's a symbol to say that, hey, all side lengths are the same. We know, and it doesn't matter as much in this case, but that each angle in the corners is 90 degrees. That all the side lengths could be the same and it's not a square, right? You know what it could be? If all the side lengths are the same for a quadrilateral, if it's not a square, do you know another name you could call it? And it blew me away that my child who's in kindergarten for like 3-4 weeks is coming home with this word. So that, like, she says the word rhombus. It's crazy, right? Like, she sees it and they don't even say the word diamond or anything anymore. Like, she says, oh, rhombus. And like, if she saw something that looked like, you know, it says, oh, you know, it's not 90 degrees, right, at each one, but yet they're all the same length of size. What do you call that shape? A rhombus. Crazy, right? Or if you had 6 sides, what is it? It's a hexagon. If it has 8 sides, it's a octagon. But like in kindergarten, right? Like this vocabulary is being built up. She has like 30, 45 minutes of homework every night in kindergarten. I know. That's crazy. Isn't that? Right. And the key, like anyone, right? I could do the work for her, but that wouldn't do any good, right? Like if I did the work only for you, right? That doesn't help. I try to help with you. Okay, what am I doing with this square panel? It says, can you see the sentence that starts with the first step? What does it tell you? You read it. Remember me just doing it for you. It's like my 5-year-old. I can't just do it for her.
We already did that one.
You read that sentence?
Yeah, around the
No. Read that sentence again that says the first step is to. So what do I do with that square panel? So it says the first step is to cut out congruent squares from each corner. What do you think that would look like if you cut out congruent squares? So do you see the corners? In each corner, what's going to be cut out? Can you do that? Does it tell me the size of the square you're cutting out? No. It just says you're cutting out squares. And then once you remove the squares, so I'm going to make them a little darker. Is that okay? So because I'm making them a little darker, it just means it's going to be what? Removed. I wonder, can you picture in your brain how a box will be made out of that? You had a square, you cut out 4 squares in the corner, now a box is going to be made out of that. Do you understand how that would be? By your faces, it sounds like no. So let's look at this. Let's say I have a piece of paper. I'm going to do my best to create a square out of 8.5 by 11. Okay, so do you see the square in front of me? Talk to me. The video's boring if I'm just talking. Right? What am I going to do to each one here? What am I going to do? I'm going to take out a square. If you actually physically see it, it will make more sense, correct? So let me do this. So, I mean, they're not completely accurate because they should be congruent, but it's just, I'm going to cut out a square from each corner so you can see it. One more, patience. So first of all, do you see how this describes the task? That I cut out, I'll make it just a little. You can see the square, but now there's squares taken out. Now what am I going to do to make an open box out of this? I'm going to fold it up. Good. So I'm going to fold up each side, right? And that if you fold up each side, so I just want, are you starting to see the box? So if I'm like really good, you can put like tape around it, and that some of you need a visual. Did you know that? Like if you can physically see like that what you're creating. So it's not out of paper, but it's going to be out of cedar. Now, so can you see the box? Can you see what we did? We took a square piece, cut out squares in each corner, and then you fold it up and it makes a open-ended box, right? Now, do you think it affects what size of square you cut out in terms of the volume? That's the word we haven't talked about. What do you think volume means? How much fits on the inside, right? The bigger the volume, the more stuff you can put in the box. The smaller the volume, the less you could put in the box, correct? What do you think would happen if I did small squares compared to large squares? Look at this. I feel like I'm an art teacher. I never get to feel this way. So, if I cut out small squares, how would that affect the volume? I'm going to do it right now. Hypothesize. You know what that word means? Guess, right? What do you think it's going to do to the volume? Don't go away from me, right? Don't yawn. Don't pretend you're tired. You're not. You're good. It's a late start today. Okay, what was the question I asked you? I said, if I do small little squares, right, how will that affect the what? Do you think it's going to be like make it bigger or smaller? What? Hypothesize. Think. You think the volume will be bigger? That you could fit more things in? So, can you see I did little squares on the corners compared to what I did before? And if I fold up the sides, and then look at the box again, can you see that box? Can you see how deep it is compared to the other one? If I compared the two, right? Which one do you think fits more in? The first box? Or the second box? And the problem with the second box is that it's really shallow, isn't it? Well, this one is a little deeper. The volume here, and how you can do volume of a box is length times width times height. The volume is actually bigger than the first one. So if I make the squares too small, what's going to happen to the volume about fitting blocks in? Will it give you a big volume that way? What happens if I make the squares really big in the corners? Huge. So I'm going to make the squares really big in the corners. What do you think the shape's going to look like if I make them really big? Here, see if I can. Let's do it, right? Hypothesize. Do you think big squares will make big volume? Let's see. Do you know what the shape's going to kind of look like? A tower? It's still going to be a box, right? But what's the volume going to look like if the square is too big? So I said if the square is too small, the volume isn't very good, is it? But if the squares are too big, is the volume very good? Can we look at it real quick? So if I create this, look at this. Huh? What happened? So if I cut huge squares, what's happening to the volume still is the box I'm creating, will it fit that many blocks? So let me just make sure you can visualize it. All right, look at that, it's so pretty. So, do you see the box compared to this box? Now, these boxes are made with the same square, but some boxes in terms of volume, what happened here? It has like a lot of depth but in terms of one way, but not the other way, right? And this one is really shallow. So one's really deep, right? One's really shallow. And then one's kind of in the middle, right? Goldilocks and the Three Bears. And so mathematically what we want to figure out is what square should I cut out so that the volume is the greatest? Do you honestly believe you understand the task of what we're doing today? The question is, what size of square should I cut out so that the volume of the box is the biggest? Do you understand the task? Or are you just like nodding your head? Did you like that I cut out so you can visually see how a box is made that way? So it's not just like whatever on a piece of paper. Okay? Can we come back here now again? Your little interlude. Now, one thing we don't know, and we just said we don't know it, is the size of the square to cut out. Correct? That's an unknown. What do we do when we have an unknown in math? We give it a letter, don't we? Yeah. So is it okay, because our favorite letter is always X, is it okay to call it X? So that means the side length of one square is what? So I'm going to write that right here. Side length of cut out square, right? Because we have two squares going on. A huge square, right? And the cut out square. So what does X represent again? The side length, right, of the cut out square. Now, does that mean this length here is also X, because it's also a side length? Does it mean this is also X, and this is 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 X? What does number 2 ask us? Read number 2 to yourself. Read number 2. Number 1 was to draw a sketch. I didn't draw 2. I just drew the 1. And then and again, I'm going to fill in so you can see the darkest spots of the parts that are going to be cut out. What does number 2 ask for? The toy box will be square and x 8 inches deep. Do you think that x represents how deep the box is? When you fold up the sides, whatever that x is will tell you how tall the box is. So when you fold it up, right, when you take out a square, whatever that x side is tells you the height of the box. Yes? So when I cut this out and fold it up, that x represents the height of the box. We can also say that, right? So you know. So what does x also represent? It's the same variable, right? It's not only the side length of the cut of the square, but it's also what? Of the box. The height of it. So when you fold it up, how high is your box going to be? Is whatever that unknown is, right? We're trying to figure out. So ultimately we're trying to figure out what height a box will give us the most volume. We're together. Comprehending, right? Not just reading. So it says write an expression for the side length of the finished box. So a box has height, and we said the box height is x inches, correct? A box also has length, and a box has width. Now, because the box has a square base, do you see that it's a square base? The length and width of the box is actually going to be the same length. Yes? Why is it the same length? The length and width, why are they the same? Because the base is a square. So if I said how long and wide is it? Because it's a square, it's the same length. So what would describe the length or the width of it is this distance here. Do you see how I'm drawing an arrow from here to here? It's the same length all the way around, but there's one right there. In fact, if I go from little square to little square, that's what's left for the length of the bottom. Algebraically, how do I write that expression? Well, let's think together. Before I cut out squares, how long was the side? And then what did I do? I took out how many squares? 2 of them, right? When you take out something, what is that mathematically? Adding, subtracting, multiplying, or dividing? Subtracting. Thank you. And again, how many did I subtract? Out. 2 of them. So how many x's is that? But it's not x times x, but it's just x plus x. Do you see how these 2 x's here? How many x's are you taking out? You're taking out how many x's? 2 x's. Can you see that? 1, 2. When you take out, that means subtracting. So how many what was the length to begin with? And then you took out how many x's? What's the width then? The same thing, right? Because it's a square. So when it says the toy box will be square with that many digits, write an expression, the answer is 24 minus 2x. That represents the length. If you're done, you can join us. You can put the test in the tray, okay? Now what does it ask for? Write an equation. Now notice an expression doesn't have an equal sign, right? Does an equation have an equal sign? Of what? In order to know the equation, is there a formula for the volume of any box? Whether it has a lid on top or not. Geometry. What's the formula for volume of a box? Length times, you guys are good, length, width, height, correct? Wow, I wonder if we have something for the length. What should I put in? Oh, I heard it. Now, I'm going to call volume V. Is that okay? V equals, volume equals. And we just said the length is 24 minus 2x. What's the width? 24 minus 2x. And then what's the height of it? What's the height? I wrote it all out for you. What's the height? Just what? X, right? All right, there's a better way to write this. Do you notice that these are factors now? Do you see one factor that repeats? How do you write it when a factor repeats? Squared, right? Each factor has a 0. And if we graphed it, that would mean that at this 0 it touches, but at x it's going to cross over. But we'll get there. Then it says, express the volume as the sum of monomials. That means, can you multiply this out? So what we're going to do, and I'm going to help you through this, is I'm going to do this, and you're going to watch and talk to me as I do it, okay? Do you have a calculator handy so that you're still participating? How do you multiply out 24 minus 2x? What do I do? Do you remember how to multiply this out? I'm going to do the work for you. You don't have to show your work because you're listening, right, and participating. But if I said, what's 24 times 24? I want you to do it for me. What's 24 times 24? What should I write down? If I said, what's 24 times negative 2? Negative what? And the same here, right? And then what's negative 2 times negative 2? Positive 4x. Okay, now, if I said, what's the power term in this box? You would say 4x squared. If I said combine like terms, you could use your calculator. Tell me what number I should write down. Negative 96, is that right? Are you adding with your calculator and participating? And then what is the constant, the number by itself? And that is just being multiplied by what? X. And if I distribute x to each one, can we now write what the answer is? So that means the volume is, remember the first one was 4x squared. If I take that times x, it's now 4x cubed. The next one, what would it be? X squared. And the last one? Plus 576x. Excellent. We're doing so well. Read number 5 to yourself. So first write this down. Read number 5 to yourself. Please, don't give up on yourself. Think, right? The question is that it has to be less than 12 inches, the square that you cut out. But do you know why? Like, think. Like, why must the square be less than 12 inches in length? Do you know why? Someone tell me. Well, there's more than one good reason why. Yes?
You said 24 inches, so that pretty much just concludes.
So if it's 24 inches and you cut out a 12-inch square from each thing, that means there's nothing left, first of all, right? Because you just cut out 12 and 12 make 24. If it was bigger than 12, well, then you have one big, then they can't be congruent because the side length isn't long enough, right? So it has to be less than 12. Here's another way to look at it with an equation. Remember the length here? If I plug in 12 for x, 2 times 12 is 24. 24 take away 24 would give you what side length? 0. If you plugged in a number bigger than 12, that answer would now be negative. Could you have a negative length for something that you're cutting out? No. Do you understand why it has to be less than 12? Beautiful. Let's write that out. It says x, I'll even put that in quotes, x must be less than 12 in order to have a positive side length, right? And positive volume. Or you could also say, if you cut out a square, so if you cut out congruent squares bigger than 12 inches, there's no wood left for a box, right? So the math and the common sense, right? The math says you can't have a negative length. Let me move this over so you can see it. My computer and the screen aren't showing the same thing in terms of what it is. So x must be less than 12 inches in order to have a positive side length and positive volume. That's the math part. If you cut out congruent squares bigger than 12 inches, there is no wood left for a box, right? That's just common sense. That there will be nothing left to build a box if it's that way. When you're done writing, turn the page over. Does someone need more time to write it down? Again, turn the page over. This is going to require a calculator to do the back page. Everyone can have a calculator. There's even some on the Chrome cart. That isn't even that far away. The back page is going to require a calculator. So when I look at your desk, if you don't have one on your desk, that concerns me in terms of direct instruction. So even though you don't see it, on top here, I want you to write the equation down again. So that's the equation, right, from the front page. What does it ask you to do? It says complete the table for different values of x. So in other words, where there's an x, what am I going to substitute in first? And then solve it. Tell me what it is, okay? Then take out the 2 and put in what number? 3, and so on. What I want you to see, does the volume change with the size of squares? And can you find the biggest volume, okay, out of that? So go for it. So plug in 2, put in the answer. And the nice thing about using my calculator, it's easy to go back and erase the 2 and put in a 3, right? Like you don't have to retype everything out once you do it once. So type it in, and then fill in what your answer is. In a moment, I'll do the first one for you to see if we match, okay? So type in 4 parentheses, 2 parentheses. Where's the exponent button? And on my calculator, do you see the button X to a little box? That's the exponent button. It's right underneath the blue circle. X to the little box is the exponent button. If you just want squared, then you can press the X squared button. Type it all in. Knowing how to use a calculator is a skill. It's not like your brain shuts off when you have a calculator in your hand. You have to think, right? Typing it in. Where's your calculator? Is that your Game Boy? What is that? That's a what? Oh, it's just it looks like one, right? Fool me. Yeah. Okay, I'm going to share in a moment, right? You can talk in your group to see, did you get the same number in your group? Can you type it in, and are you getting the same number if the side length was 2 inches? What would the volume be? That's a small square, right, from the corners? What happens if you increase it, and now it's 3 inches for the squares in the corner? I'll let you. Whatever size the calculator is like feels home to you, and you know where the buttons are, that's what matters. Did you already hand in your assignment? Yeah. So, did you get 800? Yes. And there is a unit, inches cubed. So keep going. If you cut out 3-inch squares, does that make a bigger volume? How about 4 inches? Yes. Does it get to a point where the squares are too big that you're cutting out, that the volume isn't getting bigger, but it's now getting smaller again, right? So again, you do the work. Type it in. Did you get 972?
Yes.
Once you finish the table, read number 7, and I think you can answer A by looking off your table. So read number 7, and I think now you can answer A by looking off the table. For part B, you're not writing a huge argumentative essay. You're writing a statement or two that very simply justifies why you did that. So when you said, this is the right side length, right? You made a choice, right? Looking off the table. Then the simple question is, why did you say it's that number? Why that size of square? Write a sentence down. Mustard's always causing trouble. When mayo does the right thing, it's mayo. But when she causes trouble, she turns from mayo to mustard. Right? Eating mustard again.
Something wrong?
Good. Are you playing this week? No? Next week? Never? Oh. Okay. 4. Did you get the answer 1024? That would be 1024. 5. Did you get the answer 980? And then 6, the answer was 864. So, Kate decides that she will use an integer. What does that mean, integer? Integer means a whole number. Now, technically, integer is both negative and positive whole numbers, but we don't care about negative whole numbers, right? Whole number. That means no fractions, no decimals, right? So that she does not have to cut fractions of an inch. So what value of x should she choose, do you think? Okay. And now the question is, explain why 4 inches is the best choice. I will start the prompt for you. You will finish. So cutting out 4-inch squares is the best choice because So why is cutting out 4-inch squares the best choice? Because in the toy box, right, we'll have the greatest volume and fit the most, what is it supposed, not toys, but it was actual building blocks? What was it that was supposed to? Building blocks. Hold is maybe a better word. So cutting out 4-inch squares is the best choice because the toy box will have the greatest volume, and hold, that's the word hold, I think is better than the word fit. But anyways, hold the most building blocks. Read part C. You might need that expression from the front page to answer part C. So read part C. You might need the front page, right? The expression to help you out with the, what does the word dimensions mean in this case? Length, width, and height. So again, we have an equation on the front page. So I'm going to write it down here so I can see it again. We said that the length and the width are the same, correct? And both of them are 24 minus 2x. So what did we say x was going to be again? So if I went 24 minus 2 times 4, what would that give me for both the length and width? 24 minus 8, correct? That would be what number? I know, it feels that way because whatever they're doing. I hate it. All right. do not like the feeling that the building's moving. So, I know. Maybe that's just me. So, what would the dimensions of your finished toy box be? It would be 16 inches by what? 16 inches by what? So it'd be 16 by 4. So that means the base is 16 and 16, and the height of the box is 4 inches. That would give you the maximum volume and fit the most building blocks. Now, if it's on your phone, I want you to open up Desmos. If it's not on your phone, I need you to get a computer. If it's on your phone, open up Desmos. If it's not on your phone, take out a computer. The last thing we're going to do is we're going to draw a graph with Desmos helping us. If you have Desmos on your phone, you don't. So take out your phone and open up Desmos. Otherwise, you need a computer. Those are your two choices. Either download Desmos, it's free, it's on your computer, on your phone. And what I want you to type in is the equation So I'm going to do the same thing. I'm going to open up Desmos. Once Desmos is open, can you type that equation in, please? The one that represents the volume. Yo. Yes, my computer's just acting a little slow. There it is. In this case, it's not really Y. What letter do we use? V, right? This represents the volume. Do you know why I drew the graph this way? Can you have a negative length for X? Can you have a negative volume? So that, all we want is quadrant number 1, where everything is positive. We already said the biggest number X can be is what number? 12. And we have 0 here. It has to be between 0 and 12. So when I graph this, what I want to see is, can you see on the graph that 4 inches gives you the biggest volume? And when we graph a polynomial, what am I looking at when I look off the graph? So I'm going to type in v equals 4x cubed. I want you to do the same so you can see it. Subtract 96x squared plus 576. X. And what I want you to notice is that it doesn't look very nice right now, does it? No. So right now it just looks like a vertical line going up. See that negative sign, the zoom out button? If you zoom out, can you see more of the graph and move it around? The problem with this graph is the scale. Do you see that? So if I looked at the scale, do you see where it says the wrench? You can't see it because for whatever reason the screen is cut off. But there's a wrench. Do you see that symbol? That means settings. If you do that, here, let me do it this way. Can you see that wrench? If you click on it, the x-axis, I only want the x to go from 0 to what number? Oops. I just want x to go from 0 to what number? I just want x to go from 0 to 12. I'm okay with it counting by 1, right? 1, 2, 3, 4, 5, all the way up to 12. How did I get to that screen? What symbol did I click on again? That little wrench. The y. What was our biggest volume? It was 1,024. So what I'm going to do for the y, the low volume, I'm going to put in 0. But for the big volume, I have to put in a number bigger than 1024. At least 1024, right? So is it okay if I put in like 1050? Something bigger. Why does it have to be bigger than 1024? Because that's our big volume, right? 1024. I'm not going to count by 1. What do you think a good step would we count for our graph to get up to 1,000? Huh? Bigger than 10. 100. How about 200, right? Like something bigger, right? I'm going to put in 200. And then when I look off the graph, can you see that graph in front of you now? So the bottom, if I want to know if you cut out a 1-inch square, you could go up to your graph and see what the volume is. A 2-inch, you can go up, right? If I click on the highest point on that graph, what number should I see? If I click on, do you see that turning point? Do you see the turning point? We call that a local or relative maximum. If I click, remember Desmos allows us to click on the important points? And then you click on it and it stays? Does that match the work that we did? Yes. That the high point, what's the size of the square? 4. What's the volume? And is that the work we did? So you could see it as a graph as well as working with equation. And I only go from 0 to 12. If you cut out something bigger than 12, there's no wood left for a toy box. Negative, you can't cut out a negative length from that. 0 to 12, and we see it. So last thing we're going to do is we're going to graph it on our piece of paper, and then you're going to hand it in to me. And then we're good. Not bad, right? And everyone here that did the work is going to get a 100% score in their grade book for the work they did today. So what did I count by again here? 200? That would mean the next one is the next one. Good job. 800 and then 1,000. 1024 is just above 1,000, right? And I counted here. And V is the volume in inches cubed, and X is the side length in inches, right, that you cut out? What would be important points to put on here? So, can you find where 4 is? And then you go up to what number? Hey, have we found any other points to put on our graph? What are these right here? What are these? Each one of these, what are they? Points on your... So what's another point we can put on our graph? 2 and 800. Aren't we better together, right? Than doing it by yourself? Isn't it nice to be able to read, comprehend, think? Something that happens in the real world, right? To be able to put it together. It's awful when doing a word problem and feeling alone. What feels more alone than reading a math word problem by yourself? Isn't that like the loneliest feeling ever? What's another point we're going to put on is 3 and 972. We're just going to approximate it. What's another one? 5 and 980. Another one was 6 and 864. We're just approximating them. What does the picture look like after I fill in those points? Will it look jagged like a mountaintop, or is it going to be smooth and like a wave, right, that we're going to draw it? And where does it end? It starts at 0. Where does it end? And 0, right? What are these called again? The zeros, right? We have a 0 at 0 and a 0 at 12. Remember when I said the multiplicity was 2? Did you see on the graph it actually touches here and then goes up? When you looked off the graph? But it doesn't make any sense because you can't be larger than 12. So all the answers past 12 don't make sense in the context of what we're doing. Make a curve. Can you see a lot of the work we've done the last 2-3 weeks coming together on this task? Being able to do it good. When you think you are done, then put your performance task in the tray.